This is an explanation video for Module 1, Assignment 7, Eccentricity of an Ellipse Lab. So Kepler came up with 3 laws that describe orbital motion of our planets, and his first law states that planets orbit the sun, but not in a perfect circle. Their shapes are more elliptical, and the sun is at one focal point or one foci. So for this lab, you have a couple of pre-lab questions. You need to label the parts of this ellipse and then tell me the formula for eccentricity, which is in this lab. It's also on the assignment page. If you were in person, what we would do is work through this procedure. So we would tape a piece of cardboard. I took a picture of a beautiful set of ellipses that I drew. And so I taped the cardboard to the middle of my whiteboard. And then I have a loop of string. So I would take this loop of string and I would use that to draw my shapes here. So for step 3, it says you're going to put one pin in the center. So I took my one pin, I put it here in the center, and then I took this and I used it to go around and draw my shape. Okay, so that is shape 1 out here. Shape 1 has one pin in the middle, so the distance between the foci, or capital D, is 0 because they're at the same place. There's only one focal point here. The next shape I drew is a little bit smaller. It's in here. Those pins you can see over here for number 2, they are 5 centimeters apart. So my pins were like maybe here and here, pretty close. But now, because I had 2 pins, those 2 pins, my loop of string has to go around them as well. So I'm almost making a triangle when I'm moving this around to draw my shape. And that's why this shape is a little bit smaller. Even though I'm using the same loop of string, I now have 2 focal points. Then I drew my last shape, shape number 6. And you'll notice that the pins had to be 23 centimeters apart. So they are very stretched. They were nearly on the edges of my piece of cardboard. So when I went to go draw my shape, that's why it's a little bit funky. It's very stretched out. Okay, so the pins are 23 centimeters apart here. So if I was looking for capital D, or the distance between them, I would need to write 23 there. After you've calculated all of your eccentricity values, you'll be able to see how eccentricity relates to shapes. So, like a most perfect circle has an eccentricity value of 0, and a very stretched ellipse. So for this lab, this is my most stretched ellipse. It will have an eccentricity value very close to 1. So when you're working on your post-lab questions, especially number 3, where it says in terms of Earth's orbit, what does the sun represent? Think about the shape of Earth's orbit and also think about where the sun would need to be. The Earth does not orbit the sun in a perfect circle, so it's not like it's a circle with the sun right in the middle. It must be somewhere else. I hope this helps, and if you have further questions, you should reach out to your teacher for further assistance.